Okay, hey ladies and gentlemen, welcome back. We are starting Unit 5, Day 3, so we're still solving by graphing. Okay, but we're doing a little bit more work with this. Okay, so, big question. Can a system of linear equations have two solutions? So what that means is, can two lines meet in two different places? Okay, so as we think about lines, is it possible for lines to intersect in more than one place? Okay, is that possible? Could they wrap back around and intersect in more than one place? Okay, I hope you see that the answer is no. They could not have two solutions. No, not two. Okay, what do you know about linear equations that have no solution? Okay, so no solution would mean they never intersect. Well, you are familiar with some lines that never intersect. What kind of lines never intersect? Okay, hopefully in your mind you just said parallel. Okay, if two lines are parallel, they will never intersect and they will have no solution. So parallel lines have no solution. Okay? Because there's no point of intersection. They're never going to intersect. Okay, if you need to, pause, think about that, draw your picture. What do you know about linear equations that have an infinite amount of solutions? Okay, an infinite amount of solutions. Well, that would mean every single point on the line is a solution. Okay, well, let's see here. Let's kind of draw what that might mean. I'm going to kind of zoom in here. Infinite amount of solutions. What might that mean? Okay, here's my drawing. Okay, so if we take one line and we draw it, we're saying every point on that line is a solution for this line. So in other words, what? They are the same line. So an infinite amount of solutions, they are the same line. Okay, in order for them to have an infinite amount of solutions, you'd graph them and you'd see, oh, every single point is the same. They are the same line. Okay, well, we're going to look at some real life examples because we're going to do some story problems. So Miss Beal takes a class on a field trip. Oh, how nice of her. Students could choose to go skating or biking. It costs, okay, keyword here, it costs $15 to rent skates for the day and $30 to rent bicycles for the day. Miss Beal brought 25 students and spent $450. Okay, so that's going to be a different color. 25 students and spent $450. So find the number of students who went skating and the number who went biking. Okay, so we have to think about this. First, let's talk about an equation that involves money. So let's have X equal skates, just because it's written first, and Y equal bikes. Okay, so if we're just talking about an equation that involves money, how much does it cost per skate? Well, we see $15, so 15x plus $30 per bike. Okay, 30y equals, well, how much money was spent total? Oh, $450. Okay, now let's talk about an equation. So that's one of our equations. We know we need two. Most of the time in this process, the other equation will involve the amount that was used, okay? So the amount that was used was 25 students. Okay, so the number of students who got skates plus the number of students who got bikes, that's X plus Y, equals 25. So there was a grand total of 25 students between the bikers and the skaters, okay? So here's two equations. We're gonna graph both of them. So they're both in AX plus BY equals C. Okay, so they're both written that way, so I'm gonna make two teeny tiny tables. Okay, for the black equation, my teeny tiny table will look like this. So when X is 0, we've got $30y equals 450. Okay, divide by 30, which I just did on my calculator, and I got y is 15. So 15. Okay, when y is 0, we've got 15x equals 450. So divide, oh, it looks like it's going to be 30. Okay, so x is 30. All right, so there's our graph of that, or there's our information to graph. Okay, I'm going to come over here. I'm going to graph that. Recognize that it's just the first quadrant to graph this. So I'm going to use this line right here as my x and this line as my y. Okay, so I'm going to have to go up. I'm going to erase this right here. I guess I can't erase this. Oh, that's ugly. Sorry. Okay, so I'm going to label, there's 0. Sorry, I'm writing over that. And we have to get all the way up to 30. So 5, 10. Let's go 5, 10, 15, 20, 25, 30, 35. Okay, we'll do that. And along this side, 0, let's just do the same thing. 5, 10, 15, 20, 25, 30, 35. Okay, and hope that that goes well. Okay, over here, skates and bikes. Bake. No, bike. Sorry. Okay, so graphing that table from right here. So when x is 0, y is 15. All right, here's a point. When y is 0, x is 30. Okay, so knowing that it's going to come kind of through like this. Okay, great. Next one. So let's graph that yellow equation. And again, I'm going to make a teeny tiny table, but I can see for both of these that when x is 0, y is 25. And when y is 0, x is 25. So I'm going to put those on there. We've got 0, 25, and 0, 25. Looks like it's going straight through. Like that. Okay. Hello, I see an intersection point. Okay, so in order for both of these to be true, our intersection point is, I don't like that color. Let's pick like a pink. Okay. So our intersection point is 20, comma, 5. So what does that mean? Well, X are the skates. So 20 skaters and 5 bikers. Okay? Hey, bring your questions to class. tomorrow. Okay, what questions did you have about this? Hopefully nothing with the teeny tiny table, but let me know other questions. Write it down right now and bring those to class. Have a super night.